So in the last video, we left off by defining odds definition, what odds in favor means. So it's a ratio of probability that event will happen to the probability that it will not. So odds in favor of A is the probability of A to the probability of A not happening. Okay, so probability of A to the probability that A does not happen. It's just a different way to say it. And of course, the odds against, right? The odds against something happen. So it's the ratio of the probability that the event will not happen to the probability that it will, which is that right there. So it's just odds in favor is the reverse of odds against. So let's do some examples. A hockey analyst gives the Toronto Maple Leafs a 25% probability of winning the Stanley Cup. What are the odds that the Toronto Maple Leafs will win? So odds in favor. So let A represent the probability that Toronto Maple Leafs win Stanley Cup. Okay, so the probability of A is equal to 0.25, right? And the probability of not A, in that case, is equal to 1 minus 0.25, which is equal to 0.75. So the odds in favor is just PA to P of not A, which is equal to 0.25 to 0.75, or the same thing as 25 to 75. We multiply both sides by 100, right? And then if we divide both sides by 5, we got 5. Or actually, we can divide both sides by 25. So that's 1 to 3. So the odds in favor is 1 to 3. Yeah, pretty much there. So formally, let's clear markings. Its probability of A is 0.25. Probability of A not happening is 0.75, and we already solved the rest. Okay, Yuri is playing a card game. He will lose if he draws a face card, Joker, Queen, and King, from a full deck of standard playing cards. What is the theoretical probability that Yuri will win his first draw? Okay, so win his first draw. So if you don't know, a deck of cards, and we're going to have to remember this, there's basically ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, and K. These, according to this, is a face card. So, what does that mean? Well, that means that Yuri will lose if he draws Jack, Queen, or King. So basically there are 4 of these, 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 4 of these. So the probability, let A represent event of Yuri losing. So what's n of A? Well, the number of ways to lose is 4 plus 4 plus 4, which is equal to 12. What's n of S? Well, that's just equal to 4 times 13, which is 56. 56 cards in a deck. So the probability of A is equal to 12 over 56, which is equal to, oops, not 56, 54. My mistake, 54. So 26, or 6 over 26, which is equal to 3 over 13. So that's the probability of Yuri losing. What's the probability of Yuri winning the game? Well, actually, first, since we have our answer in percentage points, let's convert our answer to percentage. So what is 3 divided by 13?
It's approximately 0.2307.
23%. 0.2307. So 23%. So you'd think it's this, because our answer is here. Unfortunately, that's a probability of losing. What is the probability that Yuri will win? Well, the probability that Yuri will win is P of A prime, which is 1 minus 0.23, because 0.23 is equal to 23%. And that's equal to 77%. 0.77. Which is, that's your answer. Okay, so get familiar with playing cards. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 types. And there's 4. There's diamonds, hearts, and in black we have spades. Whoops, that's not pretty. And clovers. 1, 2, 3 for clover. Okay, and we have an ace of diamonds, heart, spade, and clover. Anyway, the weather forecast predicts 33% chance of rain tomorrow. What are the odds in favor of it raining tomorrow? So let A represent event that it rains tomorrow. So what is the probability? P of A, 33%. And what's the percent? P of not A is 0.67%, right? 1 minus 0.33. That's how I got that, right? Which is P, let's just write it out, equals 1 minus P of A, right? So 1 minus 0.33 equals 0.67. That's where I got that answer from. Okay, so the odds in favor. So the odds in favor is odds in favor, not odds against. Odds in favor is PA to P of not A. So that's 0.33. 33 to 0.67. That's approximately double, so it's like 1 to divided by 0.33, we get 1 to 2, which is right there, 1 to 2. Susie is drawing toothpicks with 4 coworkers. Not drawing as in taking from a pack, to see who will go on a snack run. What are the odds against Susie having to go get snacks? So essentially what that means is that there's Susie and 4 other coworkers, and they're gonna draw toothpicks, and the longest one, I guess, gets to go, but you don't know what's the longest one. So that's what it means. We're drawing toothpicks. So you have 4 people, and each one takes one. Everyone takes one. Whoever takes the longest one has to go on the snack run. So what are the odds against Susie having to get the snacks? So let A represent the event Susie goes on a snack run, or picks biggest toothpick. Okay, and what do we do? Well, what's the probability she picks the biggest one? So P of A is equal, well, how many ways can she be the one to pick it? Well, N of A over N of S. So all possible outcomes is 5, and N of A is 1. So P of A is 1, which means P of not A is equal to 1 minus P of A, which is equal to 1 minus 1 over 5, which is equal to 4 over 5. So the odds against Susie getting snacks is P of not A to P of A, right? So the odds against, just the way you say it. So what does that mean? So P of not A is here, right? So it's 4 over 5 to 1 over 5, which is the same thing as saying 4 to 1. So there's the odds against Susie getting snacks are 4 to 1. Okay? And it makes sense, right? The odds against her getting snacks are high, 4 to 1. There's a 4 to 1 chance that she's not getting snacks. Against her getting snacks. It's unlikely, right? So, work questions. 2 standard dice are thrown. Determine the theoretical probability that the sum is 4A. So, theoretical probability. So how many ways can a dice be 4? 2. It can be 3, 1. Or it can be 1, 3. And if I remember correctly, N of S in this situation, if you look back, was 36, right? So it was basically that bar graph that went up like that, like a pyramid. So let A represent 4 being drawn. You know what? Let's just make a chart. A, N of A, and so A is a 4, N of A is 3 ways, and P of A is equal to 3 over 36, which is equal to 1 over 12. That's a theoretical probability. How about if it was a 7? Well, if I remember the 7 correctly, it could be 1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, and then 4 and 3, which is 1, 2, 3, 4, 5, 6. So there's 6 ways that can occur. And then 6 out of 36, which is 1 over 6. There's a probability that a 7 occurs. So that's A, that's B. C, an even number. Well, an even number. Well, you'd think it would be half of 36, right? But that's not necessarily the case. So if we look, let's just erase some of this stuff. And if I remember correctly, if we draw this out, we had the probability of it being 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And there was 1 here, and there was 2 here, 2 possible ways, 3 here, 4 ways, 5 ways, 6 ways, and then it went down. When it got to 7, 7 was most likely. 5, 4, 3, 2, and then 12 had 1. So how many ways can it be an even number? So if it's 2, there's 1 way. 1 plus 4 is 3 ways. 3. 6 is 5 ways, plus 5. Plus 5 again. Plus 10, which 3 ways for 10 to occur. And 1 way for 12 to occur, plus 1 way, which is equal to 1 plus 3, that's 4, 8, 18. 18 ways, so 18 out of 36, which is actually turned out to be half. So my intuition was right, except the fact that my intuition said maybe not. Okay, the probability of it not being 6. Well, what's the probability of it being 6? The probability of it being 6, let's just say, let's erase some of this stuff. Terrible. How do I undo? I don't think I can on this. The probability of a 6 occurring is 5 over 36. So if a rep 6 rolled, P of A equals 5 over 36, but then we want the probability of not A, which is 1 minus P of A, the probability of 6 occurring, which is 36 over 36, that's 1, minus 5 over 36, which is 31 over 36. So that's the probability that it's not a 6, is 31 over 36. And then we have not a perfect square. Well, we could add up. Where are our perfect squares? This is our perfect square, 4. We have a perfect square, 9, right? And those are our only perfect squares. We also have 1, but 1 doesn't exist. So 4 and 9 are our only perfect squares. So we could add 1 plus 2 plus 4, but instead what I'll do is I'll take, I'll take this 3 and this 4 right there, and let A represent event of rolling a perfect square. Okay, so P of A equals, or sorry, well, let's say N of A. Let's say N of A. How many ways can it occur? 3 plus 4, 7. So P of A equals 7 over 36. So not a perfect square is P of not A, which is equal to 1 take away probability that it is a perfect square, P of A, which is equal to 36 over 36, which is 1, minus 7 over 36. Basically, I'm getting 100%, which is equal to 29 over 36. So the answer here is 29 over 36. Oh, another question. A drawer contains 3 black socks, 1 white sock, 2 gray socks, all of the same style. 2 socks are chosen from the drawer at random. Describe the sample space using set notation. Okay, so the sample space is S equals, set notation. And oh my god, that's a lot. So I'm gonna pick 2 socks are chosen at random. You know what? I can only do this with, what's the probability? What can I pick? I can pick, that's a lot. So I can pick black. I can pick white. I can pick, black. I can pick white. And I can pick gray. Now, if I pick black, what can I pick next? Well, I can pick black, or I can pick white, or I can pick gray, right? Because there's 3 black socks. If I pick white, well, there's only 1 white sock, so I can only pick black or gray. Black or gray. Now, if I pick gray sock, I can pick a black sock again. I can pick a white sock, or I can pick a gray sock. So my sample space is BB, BW, BW, BG, WB, WG. Notice there's only 2. GB, GW, and GG. There, that's my set notation right there. Using set notation, show the different ways of choosing 2 socks that are the same color. Okay, so 2 sets that are the same color. Let's highlight. I got B, B. I can't choose 2 whites because there's only 1. And I can go G, G. So let's represent that with an A. So let A represent event of choosing the same color. Okay, so we have A equals, the set notation is BB over GG. That's it. What is a theoretical probability that 2 randomly chosen socks will be the same color? So N of A is equal to 2. N of S is equal to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. And then the probability of A is NA over NS, which is equal to 2 over 8, which is equal to 1 over 4, which is equal to 25%. What are the odds in favor of 2 randomly chosen socks being the same color? The odds in favor. So the odds in favor is PA to P of not A, right? So we got 25%. So P of not A, we have P of A. P of A is 25%. P of not A is equal to 0.75. So P of A to not A is 0.25 to 0.75, which is 25 to 75, which is 1 divided by 25, both sides, 1 to 3. So the odds in favor is 1 to 3. Well, not that likely, because there's so many other different combinations right here. Okay. Emily estimates that the odds against Paulo asking her to the prom are 4 to 1. Odds against. Okay, what is the probability? What type of probability is Emily applying? Well, let's see. What are the probabilities we know? Theoretical? Does she know all possible outcomes? No. What other probability did we have? Experimental? No, because there was no experiment. It was subjective. subjective probability. What is the probability that Paulo will ask Emily to the prom based on her estimate? So if we base it on her estimate, how do we do this? Well, if we turn this into a percentage, right? If we say, so that's a probability. P of A to P of not A, right, is equal to 4 to 1. Oops. 4 to 1. But let's give it in a way we can understand, right? So how can we do this? Well, we can basically divide. How do we do this again? Basically, this has to equal 1 somehow. And we have to make it equal 1 in order for it to be correct. So we got to turn it into a fraction of some sort. So what can we do? Well, if we multiply it both sides by 5 over 5, which is 1, right? So that's wait a second. Yeah. 20. We multiply both sides by 5 only. 20 to 5. And divide by 100. No, we're not going to get it. We're not going to get what we want. No, what we do is multiply both sides by 20. That's it. So 80 to, sorry, let's write it out again. So, 4 to 1. I want to change it so that essentially total number of occurrences is going to be out of 5, right? So if we multiply both sides by 20, we get 80 to 20. If we divide by sides by 100, we have 0.8 to 0.2. So that means P of A is equal to 80%. 80% probability that Paulo will ask Emily to the prom. Now, how did I know to multiply both sides by 20? Is that I want to get this, because this is, the whole represents 5, right? So essentially what this is 4 out of 5, right? There are 5 possible outcomes, and 1 out of 5. In fact, if we divide 4 divided by 5, we'll actually end up getting 0.8 to 0.2. Okay? That's actually the smarter way to do it. Yeah. Okay? So find out the whole. This represents every possible scenario for cases where it happened, 1 case where it won't. So total cases is 5. So divide both sides by 5, and then you'll have the outcome. You'll have the probability right here. Chelsea is trying out for her school play. Using subjective probability, she estimates that she has 80% chance of getting a part and 25% probability of landing a lead role. What are the odds in favor of Chelsea getting a part in the play? So let A represent Chelsea getting a part, and let B represent Chelsea getting a lead. Okay, so she estimates that she has an 80% chance of getting a part. So probability of A is equal to 80%. Probability of B is equal to 25%. So the odds in favor. So P of not A is 0.2. P of not B, because we're working with odds in favor and odds against, equals 0.75. So what are the odds in favor of Chelsea getting a part? So odds in favor equals P of A to P of not A, which is equal to 0.8 to 0.2, which is equal to, multiplied by 10, 8 to 2, which is equal to 4 to 1. So the odds in favor of Chelsea getting a part in the play is 4 to 1. What are the odds against her landing a lead role? So odds against equals P of not B to P of B. So the odds against her. So P of not B, 0.75 to 0.25, which is equal to 75 to 25, which is equal to 3 to 1. So their odds against her landing a roll are 3 to 1, and the odds in favor of her getting a part is 4 to 1. Okay, and finally, last one. A fair coin is tossed n times. N. Determine the algebraic formula that will give the theoretical probability that all tosses will result in heads. Now that's a good thinking question. Use the formula to determine the theoretical probability of tossing 10 heads in a row. All right, let's use a sample space. What's the case? I got heads and I got tails. What's NS in this situation? There's 2, right? What is, and 1 head equals 1 over 2. There's only one situation, right? Now, in this case, if I roll heads the first time, this is the second. Heads, tails. I have, heads, tails. What's the probability? Well, let's look. We got heads up here, and that's one case where it's heads in a row. So if we get 2 heads in a row, that's 1 out of 1, 2, 3, 4. 1 out of 4. N of S is 4, but we haven't changed. Anyway, we could continue through this and see if we can get the correct, we can continue on and see if we can find a pattern. Anyway, we'll continue on the next video.